Okay, Algebra 2 students, we are going to continue with the problems that you should have tried on your own. So you're just going to go through and check and see if you got them right. On the first one here, you can plug this into your calculator if you like, and you're going to do that like this. It would be press the y equals button. And then you would type -2 times 3 raised to the x, and then make sure that you're no longer in the exponent when you do plus 5. And you're going to get a table of values. Now this graph is not shifted left or right, I can tell because there's nothing up here with the x. So the numbers that you're going to be looking for on your table of values are -2, -1, 0, 1, and 2. Okay, so you have that in your calculator. You can press graph to take a look at what the graph is going to look like. And then for the table of values, press second graph, and you can see the table of values. And we said we wanted to start at -2. So you have 4.8, 4.3, and 3. Okay, and then these were -1 and -13. Okay, so -2, 4.8, -1, 4.3. And I'm making the points from the table of value. And then 2 is going to be all the way down here, something like that. All right, your horizontal asymptote is always going to be this number that's being added if it has shifted from y equals 0. So it's going to be y equals 5. So let me go ahead and put that in right now. Y equals 5 straight across. And then I'll switch color to try to sketch this in. It's kind of hard on the smartboard to graph. All right, so my domain, just like every exponential equation, is -infinity to +infinity. And my range is -infinity up until just before the asymptote. So -infinity up until 5, but not including 5 because there's an asymptote there. And as you read this graph from left to right, it's decreasing. All right, my end behavior, as x goes to -infinity, that's the left side. It's going to the asymptote, which is 5. As x goes to +infinity, this is on the right side, it looks like my graph is going down, so it's going to -infinity. Okay, here we are rewriting in log form. So write the word log. The base of the exponential is the base of your log. These two switch. So 512 equals 3. And your answer to the log should be the exponent. Write the word log. The base is the base of your exponential. These two switch. So that now the answer to your logarithm is your exponent. Okay, to write in exponential form, start with a base of 9. The answer is the exponent, and that's going to equal 27. Start with a base of 2. The answer is the exponent, and that equals 32. All right, to evaluate the logarithm here, write equals x after it, and you have 3 to the x equals 81. So you just need to start multiplying to see how many x's you need. So 3 times 3 is 9. Times 3 is 27, times 3 again is 81, so that's 3 to the 4th. X equals 4. Okay, and to evaluate the logarithm on the calculator, again, you're going to use the change of base formula. which says you do the log of the 10 divided by the log of the 7. So let's put that in a calculator. Log 10, close your parentheses, divided by log 7. Okay, so 1.18. All right, when you're ready, turn the page. Okay, so in problem 9, we had to determine whether we could rewrite these as exponents of the same base, so like in problem 7, or if that was impossible, if we had to take the log of both sides, like in problem 8. So I recognize that I can take 16 and write that as 4 squared, and this is already a 4. So this problem, we're going to do this problem like we did problem 7. So then you need to remember to distribute the 2 to the x and to the 1, and then you'll have 4 to the 2x plus 2 equals 4 to the 4x plus 1. And then once the bases are the same, you can deal with just the exponents. So 2x plus 2 equals 4x plus 1. And then to solve for x, start by subtracting 2x on both sides. Subtract the 1. So I get 1 equals 2x, 1 equals 2x, and then divide by 2. So I have x equals 1/2. Right, and now we have a logarithm. So this logarithm is already isolated, so the next step is to rewrite it as an exponential. The base of the exponential is 2, the answer is the exponent, and then that equals x minus 1. So 2 to the 3, 2 times 2 times 2 is 8. And then add 1 to both sides, and 9 equals x. And in problem 13, you have a log on both sides. So just like in problem 12, if you were to exponentiate with a base of 8, that would cancel out the log. But if you just want to cross out the log without the 8, that's fine too. So then the insides are equal. X plus 3 has to equal 2x minus 5. Oh, and I forgot to check my answer in the last problem. If I plug 9 back in up here, I get 9 minus 1, which is 8, and that's positive, so that answer was okay. All right, so back over here again, subtracting x from both sides. I have 3 equals x minus 5, and then add the 5, and I have 8 equals x. All right, so plugging that back in here, this is positive and this is positive, so this answer is good too. All right, so you should be done now with all of the problems in the packet. Make sure you go back and see if there's any missing problems in your notes or in your homework that you need to go over.